Hello everyone, welcome back to my channel The Social Pie. I am Ayan Khan and today in this video we are going to find the determinant of a 2 by 2 and a 3 by 3 matrix. Okay, so let's start the video. Okay, let's find out the determinant of a 2 by 2 matrix. Okay, so let's say we have a 2 by 2 matrix A equals to small a b c d. Okay, so the determinant of this is written like this, like absolute values equals to. Now for solving that we cross multiply, so a into d, that's ad, okay, minus b into c. Okay, so this is the value of the determinant of a 2 by 2 matrix. Okay, now let's see some examples. So let's say we have a matrix x equals to 1 2 3 4. Okay, like this. So the determinant written like this is also this is written like 1 2 3 and 4, like this. Okay, this is equals to, first we multiply the diagonals, 1 into 4, 1 into 4 minus the other diagonal 2 into 3. Okay, so this is 2 into 3. Always multiply the leftmost diagonal first. Okay, so from the leftmost digit, from this one. Okay, so this will be 4 minus, this is 2 times 3, that's 6. 4 minus 6, that's negative 2. So this is the determinant of this matrix. Okay, okay, now let's see how to find the determinant of a 3 by 3 matrix. Okay, so we have an example that is a here. Okay, so if we find the determinant of a, that is written like this. Okay, so this can be written as a b c d e f g h and I, like this. Okay, so there is a formula called the Laplace formula. Okay, so that is Laplace formula. Okay, so for that we take the first element of the first row, that is a. Okay, a times, now here it will be a determinant. Okay, not a matrix. Now if we say a, so the so if we can form a matrix of 4 elements which are diagonally located towards a, so that is diagonally it's e f h i. Okay, so this is e f h i, right? So we can write here, this is e f h i, like this, subtracted by b, this is the second element, so this is b. Okay, times, now for this we ignore a, we ignore c, and we ignore the elements down of it, so this is e and h. Okay, what we are left with is d f g i, so we take that determinant, so this is d f g i. Okay, we multiply here, so this is d f g i, like this. Now we add c times, okay, ignore these two and ignore these two, we are left with d e g h, so we write here that is d e g h, like this. Okay, now this can be expanded using the Leibniz formula. Okay, so this is Leibniz formula, that is a times e into I minus h into f. Okay, now this is the first part. Second part is negative b times di minus gf plus c times dh, so this is dh, and g minus ge, so this is ge here. Okay, now if we expand, this is a ei minus ahf. Okay, and this is here if we send the minus inside, we get minus, let's put it positive, this is minus BDI here, positive BGF, okay, plus CDH minus CGE, okay. Now if we group the positive terms and the negative terms, we get AEI plus BGF plus CDH, okay, and the negative terms are minus AHF minus BDI minus CGE, okay. So this is the determinant of a 3 by 3 matrix. Now there is one more method called the Sarrus scheme, okay. So let's see what that is. Okay, so let's suppose we want to find the determinant of the same matrix, okay, that is A B C D E F G H I, okay. So what we can do here is that we can make a bigger one of this, like this. So this is A B C, make it bigger, D E F G H I. Now close it, okay, put positive sign here. Now take the first two rows A D G and B E H like this and copy here. So this is A D G outside the determinant, so A D G and B E H. Now we will start solving. So also put a negative sign here, this is negative, negative and negative here, okay. Now go in diagonals, so this is like going here, A into E into I, so this is, and since it was positive here, so it will be A E I, positive. Now we have B F G in the diagonal, right? So this is like this, B F G, we have BFG, so we will add it because it's positive here, so this is BFG, okay. And we have C D and H, since we have made outside, so this is CDH, so we will add it, so this is CDH. Now we will work from downwards, so this is GEC, and since we had a negative, we will put a negative here, so this is negative GEC, GEC, okay. Now we have H, so this is H, F and A. Wait a second, let me put arrows, this is more clear, okay. So this is F, H and A, this is negative H, F and A. And at the last we have I, D and B, I, D and B, okay. So we have negative I, D and B, and hence we got our determinant, okay. Okay, let's look at some examples. Okay, so now we have an example here, that is A equals to 2 minus 3 1, 2 0 minus 1 and 1 4 and 5, okay, and we have to find the determinant of this matrix. So let's solve. So this is determinant of A, that is we take the first element, that is 2 here, okay. Now we multiply by the matrix that can be formed in the diagonal, so that is 0 minus 1 4 and 5. We will always take this matrix only, because in the 3 into 3 matrix, so this is 0 minus 1 4 and 5 like this, okay, minus 3 times, okay, ignore 2 and 1, ignore the middle row, okay. Now what we are left with is 2 minus 1 1 and 5 here, okay, plus this is 1, so this is 1 times, now ignore 2 and 3 and minus 1 and 5 here, okay. We are left with 2 0 1 and 4, the diagonal of this, okay. So this is 2 0 1 and 4, like this. Now we expand this using Leibniz formula, so we get 2 times 5 into 0, that's 0, minus 4 into minus 1, that's minus 1, so this is minus 4, so this is minus 4 here. Okay, minus into minus, that's a positive 3, so this is positive, times 2 into 5, that's 10, minus 1 into minus 1, that's negative 1 here. Okay, now we'll add 1 into 2 into 4, that's 8, 1 into 0, that's 0. Okay, now we simplify, so we get 2 into 0 plus 4, that's a 4, minus into minus, that's a plus, so we got 4, plus 3 into 10 minus minus 1, that's 10 plus 1, so that's 11, 3 into 11, plus 1 into 8 plus 0, that's 8. Okay, this is 8, so we get 8 plus 33 plus 8. Now we add this, we get 49 answer. Okay, now let's check this using the Sarrus scheme. Okay, so we have this matrix, we copy the first two rows and we get 2, minus 3, 2, 0, 1 and 4, like this. We write positive, positive and positive on the first three, and negative, negative and negative below the last three. Okay, like this. Okay, now let's start multiplying diagonally. So we get 2 times 0 times 5. Okay, 2 into 0 into 5, that's 0. Okay, positive 0, plus we have negative 3 into negative 1 in this diagonal. Okay, like this. So we have negative 3 into negative 1, that's a positive 3 into 1, so we get positive 3, plus we have a positive 1 into positive 2 into positive 4, that's an 8, so we got an 8 here. Okay, we got all our positive answers. Now if you multiply from downwards, that is negative 1 into 0, that's 0, into 1, that's still 0, so this is negative 0. Okay, and then we multiply 4 into negative 1, negative 4 into negative 1, that's a positive 4, positive 4 into 2, that's positive 8. Okay, so this is like this, multiply here. Now negative 5 into 2, that's a negative 10, negative 10 into minus negative 3, that's negative 30, that's a positive 30. Actually minus into minus, they cancel out. Okay, now if we simplify, we get 3 plus 8, that's 11, 11 minus 0, that's doesn't matter, 8 11 plus 8 plus 30. Okay, so we get our answer as 49. Okay, so that's how we can check our answers. So we get 49 was our answer. So guys, thanks for watching my channel. Please subscribe, like, share and comment. Thank you.